Welcome to 12.4, Probabilities of Various Permutations. Suppose 6 people line up. How many ways can they do this? Well, think about in the first position of the line, we have 6 choices. Then we have 5 choices. Then we have 4 people to choose from, 3 people to choose from, 2 people on down to 1. You might notice that that is 6 factorial, which is equal to 720 ways. 6 people could line up. Now suppose of those 6 people, only 4 get to line up. How many ways can this be done? So now we have 6 choices of people. For the first one, we have 5 choices of the people left over, then 4 choices, then 3. But that's where we have to stop. So that is 360 ways. Now how would you write that as a factorial? Well, we have 6 factorial, but we have to find a way to eliminate the 2 and the 1, so we would divide by 2 factorial. Both of these examples above are an arrangement of some or all of the elements from a given set where order matters. When this occurs, we are finding a permutation. In fact, when you are walking the halls of HP, you would observe students using permutations every day. Most students input what they call a locker combination. However, it's really a locker permutation. With combinations in mathematics, the order does not matter, but with permutations it does. When we get to section 12.5, we will discuss combinations more in detail. Let's look at the next example. In how many different ways could you arrange 3 books on a shelf if you have 7 different books to choose from? Well, think to the examples above with the lines. A bookshelf is essentially a line. For the first position, we have 7 books to choose from. Next position, we have 6. In the last position, we have 5. So using the counting principle from the previous days, we multiply 7 times 6 times 5. If we were writing this as a factorial, we could write it as 7 factorial over 4 factorial. Either way, we're going to get 210. So there are 210 total ways that the books could be lined up on the shelf. Pause the video and see if you can do the next examples by yourself. Fran Tick takes a 10-problem algebra test. Problems may be worked in any order. How many orders could she work all 10 problems? Well, since she's answering all 10, we know that there would basically be 10 factorial ways that she could answer the test. That's 3,628,800 total ways. Part B. Her teacher, Mr. Nice Guy, says she only has to choose 7 of the 10 problems. In how many orders could she work any 7 of the 10 problems? So now she gets to leave 3 blank. So if we use the same logic as above, she gets 10 factorial ways and above. However, she's only answering 7 questions, so we have to divide out 3 factorial to make it 10 factorial over 3 factorial. 604,800 total ways to answer the test. Remember from the previous notes, the probability of an event occurring is equal to the number of the elements in the event over the number of the elements in the sample space. So we're going to use what we've learned with permutations so far to answer the next example. A permutation is selected from the letters sequoia. What is the probability that it has Q in the 4th position and ends with a vowel? So there's 7 letters in the word sequoia. So we know the total permutations would be 7 factorial, which is 5,040 total permutations. Now we have to take the case where the Q is in the 4th position. So I would write out 7 answer blanks. And we know that Q is only one choice for the 4th position. Then a vowel must be in the last position, so I would go with the vowel on my next choice. There are 5 vowels to choose from. After we've assigned the Q in the 4th position and a vowel in the last position, we start at the beginning. There would be 5 letters left, so 5 choices. Then there would be 4 letters left. Then there would be 3 letters left. We would get to the next position after the Q, the 5th position, there would be 2 letters left, and then finally 1 letter left. So if we multiply all those together, you get 600 ways to arrange a Q in the 4th position and a vowel in the last position. So the probability, the key was probability. So the probability would be 600 over 5,040. You should always reduce, so that's 5 out of 42. If you like percentages better, that's about 11.9%. Pause the video again and try the last example. 11 girls try out for the 11 positions on the Highland Park varsity soccer team. If the players are selected at random positions, what is the probability that Mabel, Sue, or Deidre is a goalkeeper? So start off with thinking about 11 positions. The first position we'll call goalkeeper. We have 3 choices for goalkeeper. After we pick our goalkeeper, we have 10 girls to choose from, and so on all the way down to each position. So if you look at this, this is 10 factorial times 3. And if we think about the total ways, because it says probability again, the total ways would be 10 factorial times 3 divided by the total ways we can put 11 people in the position, so 11 factorial. This would equal 3 over 11, which is 27.3%. So if we go to our calculator just to show you how we could compute this very quickly, we can do a 10 factorial. Remember the factorial button from last chapter is going to be under the enter sign. And then times 3 over 11 factorial. And you can see we get 3 over 11. Now in part B, Mabel, Sue, or Deidre is still the goalkeeper, but Alice or Phyllis is going to be the center forward. So we're going to do it very similarly. Think about the goalkeeper. There's 3 choices. The center forward, there's 2 choices. After that, we would have 9 girls to choose the 9 spots that are left over. So there would be 9 factorial. So if we do the math for the probability, we have 9 factorial times 3 times 2 all over 11 factorial, which is 3 out of 55. Again, if you like percents, it's about 5.5%. Part C. Same scenario as B and A. Mabel, Sue, and Deidre are the goalkeepers. Alice or Phyllis is the center forward. And Beth is the left fullback. So now we've added that Beth has to play left fullback. So if we think ahead, we don't have to write all this out. We can think about that we had 3 choices for the goalkeeper, 2 choices for center forward, 1 choice for the left fullback. That takes 3 girls out of the position for the other remaining 8. So we have 8 factorial left over for the girls to play the different positions. And then the total ways we can assign the 11 girls was 11 factorial. This would be 1 over 165, which is really small, 0.6%. Good luck on your homework.